For these first kind of exponential problems, um, again, know that we can bring in logs, and that's what we're going to do here in a second when we can't actually get the exponent to be like a nice number, meaning a fraction, a whole number, negative number, etc. So one approach that we have to solving exponential equations, like I had mentioned in the warm-up, is to work on getting the bases to be the same. If the bases are the same, we can set the exponents equal to each other and go from there. So in part A, I know that I have one base is 2. I can't write that base any smaller than what it already is. So I'm going to leave the left side as is. When I look at 16, I'm wondering if I could rewrite 16 as a base of 2. So I'm thinking 2 to what power is 16? Well, 2 squared is 4, 2 cubed is 8, and then 2 to the power of 4th brings us to that 16. So I'm going to rewrite this as 2 to the power of 4, and that's because that is equal to 16. Since the bases are the same, and for things to be equal, we just need the exponents to be the same now. So I'm going to set 3x minus 8 equal to 4, where I would add 4, or add 8, excuse me, to get 3x equals 12, divide by 3, and get that x is 4. Okay, so to me, that's an easy way where we don't have to bring in the log. The log is still kind of a confusing idea. Get the bases to be the same number, and then set the exponents equal to each other. Now, where this starts to get a little bit tricky is when it's not as obvious as to what the base can be written as. A lot of us might be like, oh, I'm wondering if I can rewrite 27 as a base of 9. Well, we actually can't. We could write it as 9 times 3, but that doesn't really work in terms of it being an exponential. So then I'm like, could I maybe rewrite 27 and 9 as base 3? Because I know that 9 is 3 squared. And I'm like, oh yeah, 27 is 3 cubed. So I'm going to rewrite this whole equation as 3 cubed. Let's try this again. 3 cubed, which is that 27, and it's still the power of x plus 3. And it equals 9, which I'm going to rewrite as 3 squared, which is x minus 1. And so now this brings up an exponent property of when we have one exponent raised to another exponent, telling us to multiply those exponents. So this 3 is actually going to distribute to the x and the 3. The 2 is going to distribute to the x and the negative 1. So this becomes 3 to the power of 3x plus 9, and it equals 3 to the power of 2x minus 2. Now I have those bases to be the same. I can now let the exponents be equal to each other and solve from there. So I'm going to subtract 2x to make this just simply x, and then minus 9 to make this negative 9 minus 2 is negative 11. Okay, so still fairly quick that way. And again, not having to use a log whatsoever. Okay, so does anybody have questions here? Okay, maybe a question about the exponent properties of how I'm going from this first line to the second line. All making sense here? Okay, now if you're looking up at this and you're like, okay, I kind of see where it's going from, but I might have a hard time doing it on my own, know that, again, logs are basically created to allow us to solve for exponents. And so that's what we're going to do next, where this next kind of way of solving a problem can be applied to all of these exponentials. So the first thing, and I still like, so the way those last two examples played out, that's kind of my first line of defense, and the first way of method I'll check for is, can I get the bases to be the same? So if they can't be the same, meaning I can't take 4 or 15 and write it as a common base. If that can't happen, this is where we need to use logs. Now, there are a number of different ways in which we can do this. The most common and the most formal way is to just simply take the log of both sides. So I'm going to go log of 4 to the power of x equals log of 15. Okay, so literally didn't change either side, just simply took the log of 4 to the power of x and the log of 15. And then we can start to use some of the log properties that we talked about last week, where if I have log of 4 to the power of x. That x is my exponent. Well, it can turn into the coefficient. So this is x times log of 4, which equals log of 15. And recognizing that this is x times log of 4, I can get x by itself by dividing both sides by log of 4. So our answer, or one way to interpret this answer, is log of 15 divided by log of 4. Now I'm going to show us a couple different things because this answer can be written in more than one way. Math Excel will have you write your answers in the exact form like this. Because once we start taking the logs of numbers, we're going to get a lot of decimals. And so with a lot of those Math Excel questions, it'll have you first type it in its exact form. So let's make a note that this is exact. But then it's going to ask you to write it in its rounded form, and it'll specify where to round to. So this way of writing logs, every calculator can do that. So I can literally go to my calculator and write log of 15 divided by log of 4. Now, I want us to recognize that this is the change of base formula. So log 15 divided by log of 4 is actually equivalent to log base 4 of 15. Now, you do not need to make this connection here. Okay, we have the answer. We can type that into the calculator. We've done this problem. I just want us to see kind of where some of these other properties are coming from. So this is, again, just that change of base property. And one of our answers, or another way that we could write this exactly, is log base 4 of 15. This is going to equal the exact same value. Let's figure out what that is. And I'm going to show us one other way of how we could have gotten here as well. So for the calculator move that every calculator does is typing this log 15 log 4 in. Every calculator should have a log button easily accessible. So I'm going to go log of 15 and then divided by log of 4. And I get 1.953. We'll round to 3 decimal places. So let's call this 1.953. Okay, and this is our rounded answer. That's rounded to 3 decimal places. All right, so I want to show us just one last thing, and then we'll kind of pick away. We're going to solve them all probably in this manner, just to kind of match up with what you're going to expect to see on Math Excel. But when I see 4 to the power of x equals 15, so essentially just starting this problem over again, the very first thing we learned about logs is how we can take a log statement and rewrite it as its inverse, which is an exponential. Or excuse me, I mixed both that up. Take an exponential statement and rewrite it as its inverse, which is a log. So we can do that here. And so remember how we took an exponential and wrote it as its log form is we started with log, we kept the base the same, so log base 4, and then we switched the location of the other two terms. So this is log base 4 of 15, which equals x. Well, look at that. That is the same answer for what I got here, and if we use the change of base formula, it'd be the same answer as what we got there. So now that we're solving the equations, we see how we can switch from exponential to log form, why that works out. It all is related to, one, why we use logs to solve for exponents, and it also involves some log properties. Okay, so some of you might have just seen this right away. You're like, hey, there's an exponential. Let's rewrite it as this corresponding log. Boom, you have your answer. Okay. Now, the last thing that I want to say here, and then we'll just solve problems and I'll quit going on these tangents, is when we go ahead and solve this problem, we can choose any base. So I could say log of 4 of x equals log of 15, but we could also have done the natural log of both sides. And when you're working on Math Excel, it might say, write your answer in terms of natural logs. It might say, write your answer in terms of common logs. Either way, it's going to work out to be the exact same. This would be x natural log of 4 equals natural log of 15. X equals natural log of 15 divided by natural log of 4, which is still going to equal 1.953. Okay, so it's going to be really important that when you're working on the Math Excel here, read the full problem. Read how it wants you to type that exact form in, whether it be using common logs, which is base 10, or natural logs, which is base e. All the steps are going to be the exact same regardless. Okay, any questions here? All right, let's go ahead and do b together as well, because it's not much different. So another thing we can kind of take note of is this is base 10, so probably using common logs is going to make more sense here since a common log is a log of base 10. So let's write log of 10 to the power of x equals log of 120,000. Okay, so just simply taking the log of both sides. Now, we have a property for this. This is log base 10 of 10 to the power of x. This is going to equal just simply x. So our solution is x equals log of 120,000. If we recognize that, we're done, and you can type that in right away. Now, if you don't recognize it, it's okay because we can still get to that answer by doing the same thing. Let x be the coefficient. Divide by log of 10. And so here's our answer in its exact form. However, Math Excel is going to say that, hey, your answer's in the right form, but it's not simplified. The simplifying comes from this log of 10. Well, that is log base 10 of 10, which just simply equals 1. So this is really log of 120,000 over 1, which is log of 120,000. And then we can type that in the calculator. And we're going to get some weird decimal, so 5.079. So there's our answer, both in its exact form and decimal form. Okay. Questions here? All right, so the next kind of thing we're going to add into is just other things happening to the exponential term. So we're going to have to isolate that exponential term before we go ahead and start to bring logs into the equation. So this is just kind of like the basics of all the equations that we need to solve. We're going to actually move through this fairly decent, and I think we should get you all some time. Okay, so when I look here, there's a lot more going on in this equation compared to what we saw in the last couple examples. Right now, the exponential term is not by itself, and that's the first thing that we need to have happen. This equation, I know it's kind of hard to read, is 40. Come on, camera. 40, and then times e to the power of 0.6x minus 3 equals 237. So the first thing that we need to happen or accomplish is we need to get this e to the power of 0.6x by itself. That's going to always be your first step when solving exponential equations. Isolate that exponential term, which includes the base and the exponent itself. So this is just some of our basic solving things we've done before. I'm going to add 3 to both sides. So I get 40, and then e to the 0.6x equals 240 after I add 3 to both sides. And then I need to divide by 40. So I get e to the 0.6x equals 240 divided by 40. Thank you. To get 6. And as soon as we get here, now we're ready to go ahead and take the log or natural log, probably better here since it's base c of both sides, and come up with our answer from there. Why don't you all take it and do those last couple steps on your own. Okay. All right, so I had kind of gotten us up to this point here, and then again, I took the natural log of both sides. You actually can come up with the answer by taking log of both sides. You're going to get log base e, so it ends up being a natural log anyways. So it didn't need to be natural log, but things work out a little bit nicer this way. So I take the natural log of both sides. That property says to take the exponent, move it in front. So it's 0.6x times natural log of e, where natural log of e is just simply 1. So I could have divided both sides by natural log of e and by 0.6, but since natural log of e is just simply 1, it's 1 times 0.6x, which is just 0.6x. So then our final answer in an exact form is that x is natural log of 6 divided by 0.6, and then it equals 2.986. That's rounded to 3 decimal places. Again, make sure you're reading the Math Excel question before you start it, of how it wants its answers. A lot of them will have you type it in twice. One where it's exact, one where it's rounded to however many decimal places they say. With a lot of these, you're going to need a calculator, and the phone calculator just simply won't cut it. I've been pushing you all to try to get a TI, either 83, 84, or even the older models, but for those of you that don't and know that you won't get them, know that there is an app that essentially looks just like this right here. Okay, it is called Taculator. I'll share that with you. That's something you can download on your phones later. You should not be doing that right now. I don't want to see it in class because we still do no phones in here. But for when you're at home, that's one way that you could still kind of get access to this type of calculator without actually having one. Okay, so it's called Taculator. Okay, now that we kind of have some different strategies, why don't you all go ahead and solve this problem from start. The exponentials are already by themselves. Actually, I lied. This one turns out to be weird. Let's do it together. Sorry. What's going to be weird about it is the fact that we're going to try to keep our answer as exact as possible for as long as possible. So what all of you would, or what I would hope a lot of you would go ahead and do is just simply take the log of both sides just right away. And that's again because we have both exponential terms all by itself. Now the reason that this is going to be different is because we have different bases here and because we have multiple exponential terms. So I'm going to do the same thing where this exponent is going to move to be the coefficient, but notice how we have multiple terms in the exponent. So we need to keep those terms grouped together. So I'm going to use parentheses. So x minus 2 times log of 5 equals 2x plus 3 times log of 4. Now where this starts to get confusing is a lot, like we still are getting used to the fact that log of 5 and log of 4, they're just numbers. Okay, they're just coefficients. Yes, we have log in there, which makes it kind of odd, but this is just a number. Okay, just like 3, just like 2. And when we have numbers outside parentheses, we distribute them. So we're going to distribute this as log base 5 or log of 5 and log of 4. So we're going to end up getting a lot of terms here that involve logs. Again, it's just a number, but this is how we can keep our answers exact. So this is x log 5 minus 2 log 5, and it equals 2x log 4 plus 3 log 4. And so our task is to get x by itself. Now, since we have multiple terms that have an x in them, we're going to get those to one side, and then we're going to factor out an x from both of those terms. So I'm going to do two things here. I'm going to add this 2 log of 5 to the right side. At the same time, I'm going to subtract 2x log of 4 to the left side. So this is x log 5 minus 2x log 4. And then it equals, so adding 2 log 5 to the other side, plus 3 log 4. Any questions up to this point? One's good? Okay. So So now on the left side, I'm recognizing that both of these logs have an x, right? If I were to read this with all the operations, it'd be x times log of 5 minus 2 times x times log of 4. Since I'm multiplying by x in both of these terms, I can factor the x out. So it's x times log of 5 minus 2 log 4 equals the same right side. That has not changed. Yeah, one of those is wrong. It's 2 log 5. And so now to get x by itself, since we're multiplying by these two logs that are grouped together, we just need to divide by everything in parentheses here. So x equals 2 log 5 plus 3 log 4 divided by log 5 minus 2 log 4. And I believe this is how Math Excel will have you type your answer in. Luckily, we don't need to do any log properties. That would make this just a little bit more work, where we could combine the logs up top and on bottom to write them as a single log. And we could work to kind of combine all these together. But I don't think that's something we need to do. Know that this all represents a number, though. Okay, this is the most exact way we can express this number. And then I'm going to type it in to the calculator to get the decimal approximation. Now, when I do that, I'm going to put parentheses around the whole numerator, around the whole denominator, and then I can just type it in exactly as I see it. So 2 log 5 plus 3 log 4, close it, so that's the whole top group together, divided by log 5 minus 2 log 4. So I get negative 6.34. .343. Okay, is our answer in exact form and the rounded form? Okay, and that's again the 3 decimal places. Okay, so that kind of brings us to kind of like a midway point in this lesson.